Welcome back, Earth Science students. We are on week 3 of our online learning for Earth Science quarter 4. We are going to begin talking about rivers, glaciers, and wind, and all the different types of erosion and deposition and that sort of thing that goes along with those. But before that, this next 3 days is also the first time that we're having a quiz. Okay, so make sure that you get that done and in and done as best to your ability as possible. It will be the first assessment in the assessment category, so try to do the best you can on it. If you need help or anything, remember that my office hours are always open. Pop in for 5 minutes for the whole time, whatever you want to do to improve. I'm up for anything. Okay, please excuse my voice. I have been sick. Um, yeah, sore throat. It's not going good, but we're gonna get through this. So let's get into it. All right. So sources of weathering and erosion. As we know, water causes erosion and weathering. Okay, we talked about that before about all the different types of weathering and what water can do. So the first one is rivers, and then frozen water, glaciers also can be a source of weathering and erosion. And then the last one that doesn't involve water is wind. Okay, so let's start with rivers. Where does water flow? As you probably know, water flows from high elevation to lower elevations. Okay, it always does that. Okay, what does it do along the way? Okay, so what's going to happen is as this snow and ice melts in the mountains, it flows down and it brings with it sediment from the rivers. Okay, so as it's cutting through all the rock that it's running over, it's going to bring some of that with it. Okay, how does it do that? Okay, well, we'll talk about more about how it does that in a couple slides, but basically it depends on the velocity. Okay, so if you imagine a high velocity, rivers can actually carry bigger rocks. Lower velocity rivers can only carry lighter rocks. What features can form from it? We're going to go over a lot of these deltas, oxbow lakes, meanders, all those things we'll talk about in this section about rivers. All right, so to talk about rivers first. So there's two different types of weathering that rivers do. Like we talked about, there is mechanical weathering that water can do, abrasion and all those sorts of things. Then there's chemical with oxidation and all those that we talked about previously. So those are all fair game for rivers because obviously they're made out of water, which is what we've been talking about before. Next, though, we have erosion. Okay, so the erosion of rivers can form V-shaped valleys, watersheds, and then we'll also talk about the difference between heavy and light particles and how they affect them differently. Okay, and the next thing that we need to talk about is how they're deposited. Okay, so the depositions are braided streams, deltas, and meanders, and we'll talk about how each of those is slightly different and what they can create as well. So, just real quick, if you look at this graphic that I give you, we have mechanical weathering and the different types or the different qualities of water that they go with. I think you guys have seen this before. I just wanted to reiterate that this goes with rivers, obviously, because they're made out of water and everything goes along with them. Okay, so rivers and erosion. Okay, so how it happens, it depends on the particle size, okay, and the velocity of the river. Okay, so if we have small particles, okay, as you can see up here, small particles, they get suspended in the water, okay, meaning they get lifted up in the water and they travel with the river the entire way. Okay, so that's for small particles. Okay, so for example, a lot of sand particles get caught up with the river and gets carried away. Okay, the, the large ones, it's something that we call traction. They slowly get pushed. And really, if you can look at this bottom graphic, okay, right here, okay, these rocks are being turned by the river. And so eventually they do make their way all the way down the river. However, it is a very slow process and it just keeps kind of rolling and rolling as they go. Okay, so boulders are a good example of this. All right, but also something I mentioned is that the velocity also matters. So for example, if you look up the flood in Estes Park in 1982, huge volumes of water were moving at a very fast pace. So instead of those boulders slowly turning as they go, okay, the velocity was so high that it moves the boulders at a very rapid pace, and so the boulders are actually moved up into suspension like the small particles, and the small particles are also still there. Okay, and it causes a lot of damage. I mean, you guys were all alive and probably remember what it was like when we had the big Thompson flood. Similar case in Estes. Okay, let's talk about the erosion that happens. Okay, so V-shaped valleys are formed. Okay, so the river cuts out a very sharp V-shaped valley, as you can see in the picture in the upper right. Okay, so basically the river is going to cut through that landscape and form a V-shaped valley. Okay, watersheds, as far as erosion go, are the area where all the water moves to one area. So for example, the Mississippi River watershed that I show here, okay, the boundaries extend to everywhere where the water eventually flows to the Mississippi. So you can tell that even way out here in Colorado, okay, all the water is flowing towards the Mississippi River. Okay, it's all flowing down the Arkansas right here, okay, to get to the Mississippi River. Okay, and that's what we mean by a watershed. So the Mississippi River has a huge watershed, okay, whereas all the water flowing to it. Okay, a tributary is a smaller river that is connected to a bigger river. So, and you can just keep going down the line. So the Arkansas River is a tributary of the Mississippi River, and then there's tributaries to the Arkansas River and probably tributaries to those rivers too. But anytime you mention a tributary, it just means a smaller river that is connected to a bigger river. All right, so let's talk about deposition. Okay, so rivers deposition. Okay, a river's velocity is usually due to gravity. Like we said, it is due to the fact that it is starting at a higher elevation and moving down towards a lower elevation, being pulled down by gravity. Okay, when the river, excuse me, when the river levels off, it slows down, deposits a lot of rock. So remember we talked about the velocity is important, okay, because higher velocity means that it can carry heavier and bigger rocks. Okay, but when the river slows down, it's going to drop those rocks because it doesn't have enough velocity to keep carrying them. Okay, so this is usually at the base of mountains, okay, or before entering larger bodies of water. All right, so let's look at the different types. We have braided streams. Okay, so the river slows down, deposits rock at the bottom of the river, okay, and it divides up into several braids. This is the bottom right picture. Okay, so this one over on the bottom right of your screen. Okay, and as you can see, this river is depositing a lot of its sand, and what ends up happening is that there's only these narrow streams that end up as a result. Okay, the next is a delta, which is the top one. Okay, this is before entering a larger body of water. Maybe you've heard of like the Nile River Delta, which is in Egypt, because it's flowing into the Mediterranean Sea. And basically, essentially, the same thing happens as a braided stream, except it's going into a larger body of water, and therefore we're getting a lot of salt water versus fresh water being mixed. Okay, so the river slows down, deposits the sand, and eventually on the last side, as you can see, it ends up very similar to a braided stream. Now, there's other different types. Okay, so these long curved rivers are called meanders. Okay, curves in a river from deposition. Okay, so basically it's slowing down and it's going down this. So what happens is we actually get these oxbow lakes, and I'm going to try to draw this in here so that you can see what they actually look like. I'm going to do it in red so it really sticks out. Okay, so if you look at my bottom right picture, what happens is that eventually this river is going to start to erode away in here. Okay, because if you imagine it's carrying some of that dirt away, and what's going to eventually happen is that it'll erode so much away that it's going to take the shortest path, and so it'll start to flow like this. And what'll happen is this little lake will form out here. Okay, that is completely cut off from the river now because it flows around it instead of through this part. And so that's what we mean by an oxbow lake. You can kind of see it in the top picture. This is what an oxbow lake looks like. Okay, so if you imagine that part was cut off from this river, and now the river flows back around like this and it meanders around. All right, so that is it for rivers. Okay, something I might recommend that you do is that you can stop the video now and do your rivers assignment before you move on to taking notes for glaciers. Either way, this is going to be a relatively long video, so if you want to keep going, you can. Feel free to do whatever suits you, but we're going to keep going. All right, so glaciers. We're going to talk about where glaciers, or where does a glacier move? What does it do along the way? How does it do that? What features can form from it? Just like we did with rivers. Okay, so glaciers obviously are going to move also from high elevations to low elevations. Along the way, since it's ice, it's going to cut through things more than rivers do. Wider areas, bigger things. We'll talk about how it does that and what it leaves behind, and then the features that can be formed from it. All right, so let's start with glaciers. Okay, so first of all, we need to describe the weathering, the erosion, and the deposition, just like we've been talking about. Okay, so it has mechanical weathering called plucking, which we'll talk about, abrasion. Okay, and this leaves, from abrasions, it leaves striations. Then we have erosion, U-shaped valleys, cirques, horns, arêtes, hanging valleys, and then for the deposition, we have moraines. Okay, and then lastly, we have boulder erratics for our depositions. Okay, so let's start with the alpine glaciers. Obviously, alpine glaciers, alpine meaning that they are in the mountains. Okay, you get a lot of glaciers in the mountains just because of the freezing of the snow, and then depending on where it's at, it may never get melted, and so it just builds up and builds up over time. But that's what alpine glaciers do. So they form U-shaped valleys. Okay, the large valley formed from moving glaciers. So if you imagine this top video, or this top picture, I mean, as the glacier moves through, it cuts out a very, very wide swath of land with it. Okay, not like a river, which is going to be a smaller V-shaped valley with really steep sides. This is going to cut out a much larger area. Okay, the other thing you get is something called a hanging valley. This is where two U-shaped valleys intersect, so they kind of make like a cross. If you imagine, if you're looking from the top down, if you have a U-shaped valley that was cut out this way, and then a U-shaped valley cut out this way, okay, in where they intersect, what we have is what we call a hanging valley, because one of them is going to cut out deeper than the other one. And so what we result with is it typically has a waterfall, like in the bottom right. You can see a U-shaped valley, but then this down here is also a U-shaped valley that got cut out deeper than the top one. And what ends up happening is you get this waterfall because there's this buildup of water here, and it's going to fall down into the water of the other U-shaped valley. All right. Also with alpine glaciers, we have three more. We have horns. Okay, this is a peak formed by glaciers eroding on all sides. I like to call these ones the lonely mountains because they are the just peaks with nothing around them. Okay, so that means that at one time a glacier eroded around on all sides, or maybe even multiple glaciers are cutting away on different sides and leaving just that one peak. Okay, an arête is a ridge between two U-shaped valleys, which you can see in this middle picture with this guy that's walking across it. So if you imagine there was a glacier on this side and there was a glacier on this side, and basically they cut out and they left kind of like a mohawk down the middle, that's called an arête. Okay, and last is the cirque. This is the carved out bowl where glaciers start U-shaped valleys. So basically what happens is we have up high in the mountains, we have these things called cirques. And what they do is they keep storing more and more snow, more and more ice. And because they're in this bowl shape, the sun never gets in there to melt the ice or the snow. So after years and years of buildup, more snow, more ice, more freezing, okay, this stuff is going to build up. But eventually, the laws of gravity are going to take over and they're going to start pulling that ice back to Earth. So they're going to pull it down the mountain. And that's when glaciers start moving, and that's when U-shaped valleys start forming. All right, and then deposition. So we have alpine glaciers. So we have boulder erratics. Basically, what this means is that the glacier picked up a rock from somewhere else and deposited it somewhere else. Okay, so for example, what they do is they see these weird shaped rocks lying on other rocks, and these two rocks are very clearly not from the same spot. So this one, this big one, and this one, two very clearly different rocks. They weren't naturally like that. Something must have carried that big boulder down and left it there. And that is from glaciers moving, and that's what happens. Okay, and then the other deposition for alpine glaciers are what we call moraines. And these are piles of rock debris pushed by a glacier and left after it melted. Okay, so if you can kind of see this one in the bottom right, as this glacier moves down, it basically cuts these U shapes. And so we get a pile of rock here in the middle, and we get some on the sides, and it's actually pushing on this stuff too. So it's creating a wall there too. And so we have three different types. We have lateral, which are these ones right here, the ones on the side. Okay, that's what my arrow is supposed to be going to. So this is a lateral. Let's see if I can type. Or I mean right. Lateral. Pen doesn't work. Okay. Next one we have medial. That's the middle ones. That's this one right here. Okay, and lastly we have end, or sometimes called terminal, which is these ones right here. So those are the terminal ones. Okay, now I've showed a picture of the Great Lakes up here because that is exactly how the Great Lakes were formed. Basically, during the Ice Age, there was a big glacier over Canada and what is now Michigan and all those states. And basically what happened is as the glacier moved south, it started to melt, and what was left over, the state of Michigan that is in here, okay, is basically just a giant medial moraine in between these glaciers that were being melted as they moved southward. Okay, and so obviously they left behind big lakes because of what they cut out. Okay, and so again, I will give you a chance if you want to go switch over to do your glacier assignment, go for that. If you just want to keep watching and keep taking notes, that's fine with me too. Whatever works best for you, but we are going to go right into wind. Okay, and we're going to talk about, again, the weathering, the erosion, and the deposition. So the weathering for wind is by abrasion, okay, only abrasion. That's all we have to worry about with the weathering of wind. Erosion forms lows and dust storms. Okay, those are the big things that we have to worry about with erosion of wind. And then finally, deposition is sand dunes. Sand dunes. Okay, so let's talk about weathering. Abrasion, the mechanical weathering of sand grains from wind on rock. Okay, so they form these interesting little rocks. Here in the desert, basically they don't get a lot of rain, so it doesn't wear down by water very much. It is the wind that causes these weird shaped rocks. And these are actually called ventifacts, rock formations weathered from wind. All right, and then wind erosion. So like I said, dust storms or the erosion of surface oil from wind. Okay, if you get big uh, things of wind, you can have giant dust storms that take all the topsoil off of the earth and just kick it up, and it's really not something that is fun to deal with. If you've ever seen a dust storm or been through a dust storm, even a mild one, they are not fun to deal with. Okay, they can culminate in very large storms, um, depending on where you're at. The severity can be really bad or mild. Okay, a loess is when fertile soil is eroded and relocated to a new area. So if you look at my bottom right image, okay, the reason that we have a lot of fertile soil through the Midwest is actually because of this. It's brought here from other places, and that's also why there's also I'll show you this picture later, but they can also pinpoint that there's fertile soil that comes all the way from Africa over to South America because of the strong winds that carry that sand and soil all the way over there too. Oh, here's my picture. Okay, so you can notice from the Sahara Desert up here in Africa. Okay, so this is Africa. Okay, that's the Sahara Desert. Okay, they can find these particles all along the coast of the Amazon rainforest in Brazil and South America. Because yeah, the wind will let it travel that far. Okay, so it kind of moves in different ways. So what I want you to recognize with this middle picture right here, okay, make sure that you realize it's very similar to how rivers work. Okay, so we have small particles that are in suspension. Okay, remember again that it depends on the velocity. So rivers and wind are very similar because the velocity is the thing that matters the most. Okay, high velocity can carry heavier rocks. Okay, high velocity wind can move heavier rocks. Higher velocity rivers can move heavier rocks. Okay, so suspension for both of them is the movement of small particles. Okay, and then we have these kind of like these medium particles, and it's called saltation. And what it does is like there's enough to get it in the air, but not sustain it. And so kind of what it does is it bounces along. Okay, so it lifts it, bounces, lifts it, bounces as it goes. And then the last one is called creep. This is a very slow erosion. Okay, very slow, where the wind just kind of pushes these rocks and they just kind of flip over. Slowly and surely they just flip over, but eventually they get moved to a different spot, if you imagine, but it's over years and years of erosion that actually happens. Okay, so deposition for wind, sand dunes where the wind velocity uh, slows down and deposits particles. Okay, you can tell that up here it's kind of cut off, but either way, okay, we have the wind push it up here, and then when the wind finally slows down, it deposits the sand on the other side, and it forms these really, really hills. I mean, you guys probably have seen sand dunes before, um, but that's essentially because of the wind that is carrying those sand particles and then depositing them when it dies down. Okay, and that's all I have for you guys for this week. Make sure that you do your quiz and make sure that you do your assignments. I want to give you guys props for most of you keeping up with your assignments. You're doing a lot better than my physical science class, so I thank you. And we'll just keep going. So we are almost to the end of this unit actually. So look for a unit test coming up probably in a week. Okay, probably in a week. So I'll see you next time. Thanks for watching.